Okay, Kim, we are starting to get into chemical equations now, finally, in chemistry, which is when things start to feel like, oh wow, I'm like actually doing chemistry, not like all the background stuff. Um, so that's funny that we're kind of ending with like, this is real chemistry. But the first thing we're going to talk about is word equations. So chemical equations are just like recipes for cooking, just for chemists. And like I said before, chemistry is just like cooking. You just can't lick the spoon, and sometimes the food fights back, which is why we wear safety goggles and gloves and things like that. Chemical equations can be expressed using symbols and chemical formulas, which is typically what you think of when you see chemical equations, or they can be expressed using words. Chemical reactions are literally everywhere around you. Every chemical reaction has a chemical equation that's associated with it. They're happening in your body right now as you digest food, as your body is moving oxygen from your lungs to the rest of your body. They're happening in your window or outside your window, in the environment as plants convert sunlight into food. They're happening in your Chromebook as you work, while the battery is running, and even while your battery is recharging. You can't escape chemistry. I am sorry. It is everywhere. In math class, you've used equations before, like algebraic equations and things like that. Chemists keep track of chemical reactions also just by writing equations. So we have that in common with math. In any chemical reaction, there's one or more substances called reactants that are converted into one or more new substances called products. So remember, a chemical change, we have new substances at the end, versus physical change, you have the same thing that you started with, it just might look a little different. The general form of equation for processes in chemistry look like reactants converted to products. The arrow is just like an equal sign in math, but scientists say yield or yields, not equals. So yields is kind of a word that means like produces. We can describe chemical reactions by writing a word equation. So this is where we basically replace chemical formulas with words. So rather than reading the chemical formula or things like that, we say the name of the substance. So this is where nomenclature becomes really important. It's kind of how chemists understand one another and understand what's happening in a reaction. So for example, when silver metal is exposed to sulfur, it reacts to form silver sulfide. Too many S's. So silver sulfide is commonly known as tarnish. If your mom has any like nice silverware or things like that that's actually silver, she has to polish it often. And girls, you might also have jewelry that's real silver. Sometimes it has this tarnish and you have to clean your jewelry. Basically, the surface of the silver gets dark and it gets like a streaky black coating on it, and that is silver sulfide. So the word equation for this process is silver plus sulfur yields silver sulfide. The reactants are silver and sulfur, they're on the left side of the equation, and the product is silver sulfide, that's on this side. Sometimes you have more than one product, sometimes you only have one reactant, so the numbers don't really matter, it matters which side of the arrow these things are located on. Another word equation we can use is when methane gas, is when methane gas is burned. So methane is a major component of natural gas. Things like your Bunsen burner or your kitchen stove at home use methane to make that flame or fire. Burning, usually we use the word combustion in chemistry, is a chemical reaction where we have some sort of fuel reacting with oxygen gas, O2, and that's in the atmosphere. We breathe oxygen and things like that. The products of burning combustion are commonly carbon dioxide and water gas. Sometimes you have other products, but you're definitely guaranteed to have carbon dioxide and water gas. So the word equation for this reaction, when methane gas is burned, is methane plus oxygen yields carbon dioxide and water. So even though they didn't give me all that information in the sentence, I know that based on the word burned, combustion. I know carbon dioxide and water are getting made, and I know it burns in the presence of oxygen, so oxygen is the reactant. So even though they only mention methane, you can kind of fill in the blanks for different equations. The reactants are methane and oxygen. They are what you start with, and the products, what you end with, are carbon dioxide and water. Word equations are useful, but they do have their limitations. So they can't be used for any work involving numbers or calculations because there's no numbers in the word equation. A word equation doesn't tell how many moles of each reactant or material are needed or how many moles of product are formed. So moles is what we use to measure the amounts of reactants and products. That's our useful measurement or unit. So for review, you should be able to write the generic form of a chemical reaction. So what do we start with? What do we end with? And what's that symbol that goes between them? What are reactants? How would you define them? And what are products? How would you define a product? Okay, so that is it for the 11.1 notes. And that's just going over word equations.